Welcome to Physics Lesson 6, Potential Energy. Please open your booklet to page 53. Now on page 53, we will see that potential energy is energy due to an object's position or condition. It's the potential for an object to do work, or stored energy. Now, there are different forms of potential energy. We have elastic. That's an object is elastic if it always returns to its original shape. Please copy this red stuff down in your notebooks. We have chemical. That's energy in bonds of chemical compounds. We have nuclear. That's nuclei that have the potential to split. And we have gravitational potential energy. Now, this is potential energy due to position above the ground. Please take a few minutes to copy this down in your books. Okay, pause if you need to, or we're moving on. Continuing on page 53, we'll see that EP, that's potential energy, is equal to our recent friend work, or EP equals mgh. That m is the mass in kilograms, g is gravitational acceleration on Earth, or 9.81 meters per second squared, and the h is height in meters. And of course, potential energy will be in joules. Please make sure you get this down in your booklet. Bottom of page 53. Okay, moving along. So, potential energy is a form of energy, so it gets the following units. EP is equal to potential energy, which is equal to units of kgm times m over s squared, or nm, or joules. Please copy this down in your notes on page 54. Now, how on earth would I expect you to understand all this before we put it into action? And the answer to that is I don't. So, we're going to take our new fancy equation and we're going to put it to work right now. So, into the first example on page 54. So our pal Bladen put their physics homework on the top shelf of their locker. The shelf is 1.8 meters high and their homework has a mass of 500 grams. How much potential energy does this homework have? So, when we don't know what to do, we do what we know. And we know that our old friend Grasp will help us out here. So let's start there. Now what does this give us? Well, let's just take a look here. So we know from this little paragraph that the height is 1.8 meters, okay? And the mass, 500 grams. Okay, but we're going to need that in kgs. So we're just going to divide that by 1,000. And that'll give us 0.5 kgs. Okay, then we know gravitational pull is 9.81 meters per second squared. Fantastic. Okay, now let's move along. So what is required? Well, how much potential energy does this homework have? Okay, EP equals question mark. So now let's play with our new equation. Let's analyze this. So we have EP equals mgh, but we're not looking for EP. Sorry, we are looking for EP, and we're just going to plug in the numbers. So we have 0.5 kgs times 9.81 meters per second squared times 1.8 meters. And we're just going to plug that all in. We get 8.829 joules. And then, of course, we have to round that up. We're going to look at our significant digits. We'll see that the 1.8 meters has 2 significant digits. So our answer can only be that accurate. So we will round it to 2 significant digits, which is 8.8. All right. And then finally, we, of course, just need to paraphrase. Boom. If Bladen's homework has a mass of 500 grams and is sitting 1.8 meters above the ground, it will contain 8.8 joules of potential energy. Please get this down in your notes. Okay, pause if you need to, and we're going to move ahead. All right, now it's your turn. So I challenge you to figure this one out. A forklift is raising an object with an unknown mass. If it takes the forklift 920 joules of work to raise the object straight upwards to a height of 3.4 meters, calculate the mass of the object. We are going to have to mess around with some equations here. So good luck. Pause the video right now and give it your best. Okay, you did it. Let's check out the answer here. Okay, so we're going to start, of course, with our old friend grasp. And we're going to move forward on that. So first, what's given here? We have work. We have height. We know the gravitational pull. Okay, so what's required here? What's it asking? Calculate the mass of the object. Big old question mark with that. So now we need to analyze. So we know that work equals EP. So that equals mgh. Okay, so we're going to need to mess around with that a little bit. So what are we looking for again? We're looking for m. So in order to switch this around, we just need to divide both sides by gh to keep it the same. And boom, we've isolated m. So now we can move over and solve this problem. Okay, so if we just plug in these numbers, we will see that mass equals 920 joules over 9.81 meters per second squared times 3.4 meters. We're just plugging those numbers right in there. And that'll give us this fancy number right here. 27.58 kgs is what my calculator says. Now I need to look at my initial numbers, and I see that the weakest link is 3.4 meters with 2 significant digits. So my answer can only have 2 significant digits, so I'll round it to that. And my third digit there is a 5, so I know I need to round up to 28 kgs. Okay, and now I'm going to paraphrase. If the forklift requires 920 joules of work to lift an object to a height of 3.4 meters, the object must have a mass of 28 kgs. We did it! Okay, pause it here. Make sure that if you didn't get this on your own, that you copy this down so you can figure it all out. See what you did there. And then let's have a little party. Celebrate. We did it. We did it. Way to go. Congratulations. I am so proud of you. Now, please complete the practice questions on pages 54 to 55.